Okay, so we are arriving to the very last of the conference, and Miguel is going to unveil the the secret of the conference, which is your opinion about the questions that were posed in the poll. So, Miguel.
All right. Oh, can you hear me? Is it? Yeah, I think it's okay. Okay. Yes. So I was asked to unveil the poll results, and I was thinking, like, it's supposed to. This is supposed to be sort of like a, like a wrap-up event, but it's also a bit of discussion. So we're gonna be seeing the different questions, and I want to hear everybody's opinions. So at any point, just raise your hand and please let us know what you think. It's also supposed to be fun, and I was thinking of jokes that I could make and so on and so forth. But then all the good jokes were taken yesterday by Dieter about the poll. So yes, I'm just left with the bad ones, I guess. Okay. So first of all, I mean, before we start, the show of hands, how many of you filled up the poll? Okay, pretty good turnout. Okay, I'm proud. Okay, so that's the first question. At this point, what among the following is more important to further develop the swampland program? Okay. And I thought I was going to get that drum roll for the. Can I get the drum roll? And the answers are. These are the possible answers, and this is what people answered. Okay, actually, and also more answers. So the answers that were given were dualities, holography, unitarity, global symmetries, develop phenomenological applications. And then there's a small percentage you could also fill in your own answer. And then people were they were saying things like holography plus symmetry, so combinations of the two, and focus on non-supermatic setups, more swampland geometry, social breaking. Not sure, but not the above. That's helpful. And I actually, I didn't write this last one, but I actually quite agree with it. Develop worship techniques. Like we're supposed to be string theorists most of the time. I'm the first one to mostly do supergravity and throw the occasional brain. Okay, so it's interesting, I think, and I think this is a shift from past polls have been involved in. There's been a shift like this. The way the answers you get in a poll also depend on the way you phrase the questions and the audience and the atmosphere. But certainly, in previous iterations of questions similar to this one, we would have some, like a lot of people would think duality is the way to go. We tie with holography, and in this one, holography is the clear winner. So it seems like there's a shift. People are thinking that holography is really the way to go to the future with swampland constraints. So does anybody have any points, any comments to make to this one, and any strong feelings that should be voiced, or not strong? Any kind of thing. Jake, please. Wait for the mic.
Yeah, I think maybe just to say, and I think this is sort of underlying, but maybe not said so explicitly so often, but like the holographic principle is itself a swampland condition. If you write down a generic path integral, Euclidean path integral over Euclidean gravity, there's absolutely no a priori reason why this should become a local system on the boundary. And so demanding that a theory be holographic is a very powerful constraint. And in fact, it implies lots of different swampland conditions. So this is why I think holography is sort of a unifying swampland principle. In some
the
sense.
Thing behind it.
Yeah, exactly.
Yeah, I kind of agree. I agree that holographic principle is really, really deep, and you can actually hope
and non-trivial.
And non-trivial.
Right, it's not for free.
Yeah, we got a mileage out of it, and maybe we can get even more. Okay. Anyone else wants to make a comment here? Okay, let's go to the second question. Come on. That's not good? No? Okay, Fernando, tell me what to do. I keep, there we go. What is the most, I do have a pointer, that's right. What is the most pressing question that we should be addressing in the next few years? All right, now we're talking. And these are the answers. This was a free, free answer. Like you could write down whatever you like, so that people could, do whatever. And of course, I mean, I actually, I was one of the people who wrote. I forget if either dark energy or the scissor. I really think like this is really a quintessence or any kind of reasonable model of dark energy, trying to get that from string theory or rigorously rule it out from swampland perspective? It's certainly, to me, the most important question that we could be thinking on. It's a difficult one. Closely, in my view, closely related to it is the issues of scale separation. It's like it's a similar, probably easier version of similar question in ADS, which in principle you can attack more rigorously. And then we also had like the third most popular answer was no supersymmetric scenarios. Okay, it's true. A lot of this I think actually an issue, or like a weak point of swampland approach. We want to make general statements. A lot of the evidence that we often get is supersymmetric, and I'm sure that at least in some cases that's a red herring. So developing technologies for non-supersymmetric scenarios is certainly very important. What else do we have to determine most of the other members of the conjectures? Yeah, I wish I could do that. Proofs of some conjectures, M theory, model stabilization, understanding generalized finiteness constraints. You see, there's actually a lot of them which are variations of the other ones, like cosmological constant relation with hierarchy problem. These two are similar, they're related to this one as well. I'm sure people have opinions on this. No? I am seeing it the same as you. So let's see. If I hit this, what happens, Fernando? I'm gonna. Oh, that was too bad. Okay. I'll view slideshow. Well, whatever. So understand generalized finiteness constraints, and I think that's the last one I can see. Naturalness. Oh, naturalness. Oh, I know who wrote that one. Yes, please, please.
Yeah. Comment. I wrote something for this that I no longer believe in. I think
that's great. That means there was real progress in this conference.
Well, I'll tell you what, I think what was maybe the most compelling thing for me that changed my mind was the colloquium that Matt Reese gave, wherever he is. I think that what really has distinguished the swampland, I think, his just like the group of people who tend to do swampland research, it is largely the string pheno community. And I think that especially if we're talking about questions that are that we're attempting to make contact with observation, like with de Sitter, like with inflation, dark energy, these sorts of things, it's important for us to be guided by trying to make predictions into the things that experimentalists are going to be able to make progress on. I think that was something that was exciting from his colloquium, is where you can see where these are where future experimental bounds are going to come in. I think what would really be exciting if we as a community could make a prediction before, coming from string theory before it can be revealed by experiment.
Yeah.
So I think de Sitter is one example where, obviously there are experiments looking at looking for the equation of state parameter and seeing is dark energy time dependent. But I think, an important lesson from the colloquium and more generally, it's just that there are a lot of other experiments that are interesting and coming out too, and we shouldn't lose sight of those and zero in so much on one issue.
I see. So that's a very good point. So you originally voted for de Sitter or something like that.
I think I said inflation or something,
okay.
but I think there's I think maybe stuff. Talking to phenomenologists or experimentalists could be a very good
I absolutely agree. Like there's many things. So one question, for instance, it doesn't have like direct experimental connection in principle, but something that I'm very interested in, and which I think the swampland could say something, is like, what is the global form of the standard model gauge group? Like that can have impact on what action couplings you can have, that kind of thing. Any more? Yeah, Irene.
Yeah, following on this, I think I agree, and I think I feel that if we could give some new resolution, like that we are really confident about, not just indirect evidence for naturalness and electron hierarchy problem and all these things, like something new coming from the swampland string theory that you don't think about in field theory. If we can really provide a model, at least, I think this would be something that would change the swampland program and how people think of the swampland program and pheno people and so on. And I feel that we always try to do that because we always talk about the UV-IR mixing imposed by quantum gravity that is behind the swampland and so on, but it's always very vague. And I mean, of course, I mean, even me, like I've tried to use conjectures to use this, but like, I think we have to understand this UVR mixing that string theory imposes and make it concrete and give some, I don't know, some application to this, to some natural decision. And if we were able to do that, I think it would be a huge improvement for the Swampland program.
Yeah, I absolutely agree. Anything that is connecting, and even like as for me, it's like as Thomas likes to put it, like going back for a moment to the sitter question, even if you get like a higher dimensional, this is like a proof of concept that you can get things, even if it's not right directly in connection with the experiment, or or even phenomenologically interesting. What can you not get? It's interesting. Any other comments? Nope. Okay, let's get going then. Next question. How do you think that the Swampland program will be in 10 years from now? These are the answers, and this is what people answered. Okay, so this one also we give you like some pre-suggested choices, and there's also some pre-fields, so you could put whatever you like. So 12% of the people think it will be dead. I hope those are not the students. It will have developed, but we will be asking similar questions. I think that's reasonable. I just hope they're not the same questions. It will evolve and involve a larger community of that, by the way, was the most popular option. It will evolve and involve a larger community of physicists that I can also agree with, and in fact, the two of them are compatible. It will have made contact with experiment. I really, really wish that's true, and I think it's possible. I personally am also not certain. I think it will be enough at some point to restrict field theory space, dilute within the larger body of knowledge string theory, in hibernation, develop into, well, actually it was in hibernation before, right? Like the Wigwright papers 2007, and then hibernated for 9 years until it was needed because of the bicep story. How would I know? Yeah. The point is to make a guess. It will evolve into something different. Only the community will remain, similar to another one. And okay, the last answer I thought was interesting. I would love it if something like this happens. I think that if whoever wrote this answer wants to make a comment, I would be very happy to hear. But the way I understand this answer is kind of like, for instance, in ADS, if we were living in ADS, in principle, we already know the master equation we need to solve. It's just crossing symmetry. You could imagine that since AI is able to do so many things, maybe it's not so weird to think that in the near future might be able to solve something like the crossing equations. But presently, we don't even have something like that in flat space. Right? We're getting closer, but we don't. It's significantly less understood. But I really like this optimistic take. It's like very futuristic. Anybody wants to make a comment? Please, Federico.
Yeah, so there was something I was reflecting these days. If you think about holography was clearly found within string theory. Then
Yes.
if you look at the evolution of the subject, nowadays it got to a maturity level for which it's kind of like going by itself. Especially very young people are doing research and very good research in holography, and they don't have a strong background in string theory. Would you think that in the future the Swampland will go along a similar path and detach gradually from string theory as a whole?
Well, you're asking me, or you're?
I'm asking everybody.
Everybody? Like, if you ask me, I think that the whole point of the Swampland for me is that you use string theory as a laboratory. The whole idea, to me at least, is try to identify things that you believe are true in general, and then you check against a million string theory examples, and maybe your reasoning, even if you cannot prove it, is right. So in that sense, is to me a bit logically independent from string theory. If it is to develop as something completely separate from string theory, I think you will always need a lab. So you would need to find an alternative for the lab, and I don't think we have one at present. Maybe things change in 10 years. That would be very exciting. If we discover a new class of quantum radicators in the next 10 years, I for sure am going to think about that. Anybody else? Julio, please. Julio's microphone for Julio. Sorry, Thomas.
Yeah, I wrote the last part,
Mhm.
the last answer, and actually you cut down the rest of the statement.
Did I?
And the rest
Fernando.
of the statement was
That was not me.
it was more negative. And I wrote that because I wrote, and we will not understand the answer. But kind
So-
of to say something more positive about this, I that's my way of thinking about the swampland is it's more a conceptual program to develop like minimal features of what we think of quantum gravity. I have a hard time to understand these statements about the connection to phenomenology, and it would be fantastic if this is true, what was said in the previous answer. But I have the feeling that we say this already for many years, and I'm sure we will say that in every conference for the next 10 years as well. But I think from my personal point of view, the more realistic thing is that we really formulate a set of statements in a very clean language, which have to be true. And we collect so much evidence that we actually believe in them. And then maybe this helps us to develop like quantum gravity itself rather than precise statements about experiment.
I see. Well, I will just repeat Fernando's comments that the AI already was good enough to cut down the negative part of your statement. I think, so I personally think that we should at every time try to connect with the experiment, even if it involves something else so rigorous. But I actually think that one of the strengths of this field, many fields have this honestly, but this one for sure does, is the diversity of opinions. If everybody was trying to just do phenomenology, it wouldn't be so good. If everybody was just trying to do formal stuff, maybe also not so good. But we are diversifying. We're doing a little bit of everything. I think that's great. Anybody else has a comment about this before Julio steps in?
So actually, my comment is related to this last answer and also to the answers of the previous questions, which I'm a bit surprised because I mean, as an outsider, it seems to me that part of the swampland is a data-driven endeavor. Like you have many examples you look at, you try to find patterns in these examples. And for instance, no one thought that AI or machine learning could be like a tool that could enable some progress in the next few years. Maybe people do. I know that there's people trying to explore the landscape using machine learning.
That's right.
But it seems to me that given how sophisticated some of these tools have become, especially in the last 2 years, yeah, it's something worthwhile to explore. Not exactly as described by this answer, which is we will formulate the features and then ask AI how to formulate the theory, but rather than trying to find the features and trying to find the patterns and the common things between all the examples.
Right. So you agree on AI, but you're focusing more on the bottom-up approach.
Yeah.
Like it's great for finding patterns in data, and people are, as you're saying, people are already trying.
Right.
Yeah, definitely. Like this is something which is revolutionizing everything. And Luis has a comment.
I will make an optimistic prediction.
Okay.
In 10 years' time, I think either we are stupid or we should understand the overall scales of physics, the hierarchy problem and the cosmological constant, and relate them, I don't know, with holography and duality or something. I think that's feasible. So I think I encourage the young people, of all of us, to think about it, because there are new tools to address these issues. And nobody has thought in this way about those problems till recently. In 10 years is sufficiently.
Okay, those are big words. So in 10 years, we're gonna solve. I love the optimism. 10 years, we're gonna solve the cosmological constant and hierarchy problems. Okay, understand them. Okay, fine. To me, that's solved. Okay. Any kind of understanding, like when you have little understanding of something, any progress is amazing. Any further comments by anybody? Liam, please.
Yeah, so this is both a comment and a question. It's mostly related to Thomas's remark. It seems to me interesting to understand, as a general target of the swampland program, the connection that an arbitrary general quantum gravity theory has to string theory.
Yeah.
In other words, to show that every consistent one is directly connected to string theory or to exhibit new ones. And I haven't heard that much about that at this meeting. I wonder whether people think this is an important target and where things stand.
That is a great question. In fact, it's so great that we essentially ask about it. So it's one of the questions down in the poll. Like, is a string theory the unique quantum theory of gravity, so on and so forth. Right? So maybe we defer the discussion to that one. But I feel very, very similar to the way you feel. I think it's one of the biggest questions that you, in principle, can ask with things like this is really why I'm excited about things like covariance and conjecture and stuff like that. In principle, you could, for the first time, have a handle at this kind of question, some kind of handle. Okay. Do you think that there's deeper structure underlying swampland ideas into a single framework? So this is similar to the first one, but they were just wanted to get like a rough feeling of what people are saying. So the answers were yes, no, or only a subset of them. So we basically wanted to understand if people feel that all swampland conjectures are like one connected whole, or they believe, yeah, some of them yes, but the others no. And can I get a drum roll? I don't know if I love it more when people do it. Voila. This is the unsurprisingly, perhaps, in a swampland workshop, 61% of the people think that the swampland is probably has some underlying reason. But interestingly, also 30% they believe it's just a subset of them, right? And actually, admittedly, is a very large, you know, how big the subset is. Maybe we should have asked about that. Anybody wants to make a comment about this in any way, like why you feel they're all connected to a single framework, or what are the subset that you think is connected and which one is disconnected? Any comments here? Julio, please.
And I just want to give my opinion as an outsider who's been kind of learning about many of these conjectures over this week in the last few months. And it seems to me that even though there's certainly a connection between all of them, there's a subset of them that clearly is very tightly connected, and it's kind of a more refined statement about the absence of global symmetries in quantum gravity, which also relates to covariance conjecture and some of these things.
Yeah.
Right. And then there's so I just wanted to point out that I think there's certainly like a subset of conjectures that I think there's a unifying framework, which is something that I think everyone would be on board. And then there's others that I think are like related but not directly connected to the absence of global symmetries. That I think kind of the jury's still out. Or
there are some of them which is admittedly are just, if anything, supported by data rather than like why is that? Right. Like, honestly, just to give an example, that the one that I proposed yesterday, right? Yesterday I was saying maybe every supergravity, you know, every quantum gravity has a modelized space with one corner which is geometric. Why was I saying that? Well, because I only knew 2 counterexamples or 3, and we found the geometric description for those. So now I know no counterexamples. Yeah, but you're right. There's certainly some of them, like with gravity distance, variations of no global symmetries. I think mostly everybody believes it's true. And that's the 2 approaches, right? There's the approach of trying to connect everything to these, like more rigorous, and then another one which is more like describing patterns in data. Any further comments on this one? Yes, please, Ana Maria.
Sorry, I thought the single framework was string theory.
Very good. I love that we are going, like, this is related to what Liam was saying, right? Like, so simple underlying principle for swampland. If everything is string theory, then you do string theory and then you do swampland, right? So but that's the question. Is that really true? How could we possibly even address this question? Oh, yes, I forgot. So in this one, actually, I am comparing with, here's the answer. Oh, there's a big bar here. Okay, so here are the answers to we actually asked the same question in one of the online swamp polls. This is the one from 2 years ago. I don't have the results. I'm logged out of some Google accounts. I couldn't get the last ones. Sorry about that. We have one poll in June, but yeah. But perhaps it's more interesting, you know, to compare with one from 2 years ago. There was a bit more of a distance. It's not going well, Fernando. It's going the other way around. Ah, there we go. Thank you. Thank you. Asymptotically, yeah. It matters what you do asymptotically. Okay. So, you know, you can still, the question is the same, the kind of answer is different, but you can still compare, right? So for instance, like if you add up all these big chunks, which are versions of yes, so basically the thing you compare is the no, and the no has more or less remained constant, hasn't changed too much. So I guess it's a good thing. Yeah. So we're getting to the question that everybody's asking. Like Liam was asking, Amari was asking. Are there another way of asking this question? Is are there any other quantum gravities besides string theory? Okay. The answers were obviously yes or no. Just to tell. And this is what people think. So 45% don't like to guess. It's like just it's too soon to tell. Sorry, don't ask me this thing. Come on, let's try. And then out of the people that answered, you know, in a conference which is mostly string theorists, I guess that they believe pretty strongly in string theory. But it's a sizable chunk of people who believe there's other quantum gravities. Okay, so I'd love to hear anybody. I think it's perhaps one of the on the formal front. Certainly, to me, is one of the most important questions you can ask today. And I think like Jake and Kuhn's covariance conjecture, really one of the reasons that I love it is that it really gives us a handle on this question. I don't think it's stated often, but the covariance conjecture, if it's a statement about quantum gravity, that any two quantum gravities are connected to a domain wall via the main wall. If we know a quantum gravity which is n equals, for instance, I don't know, 8s factors of 5 or n theory and T6 or your favorite compactification, that means that in a sense, every other quantum gravity is a vacuum of the same theory. And you could just say that, well, that theory is a string theory. It's just the name you gave it because that's the first vacuum of the theory you discovered, but it's just one single thing. So if covariance conjecture is rigorously true, then indeed there's a unique quantity of gravity, and you can call it string theory. And covariance is in a sense an extension of the global symmetries. So I feel, you know, it's interesting. I used before the covariance conjecture, I was in this 20% simply, I don't know, because you never know. And just to belabor this point a little bit, if you apply a covariance conjecture in ADS CFT, the statement there's always a covariance domain wall between two vacua maps to a statement about the dual CFT, the existence of a conformal interface between any two CFTs. And so you are formulating the questions of uniqueness of quantum gravity in ADS purely in field theory language. Sure, very complicated question, but still huge progress, I would say. So that's something I love to think about. And I've been trying. Any comments, sorry, one, please, Jake.
Yeah, so maybe just a comment on sort of this question and also the previous one about unifying principles. You know, I think one unifying principle from before was the holographic principle. But another, I think, very important unifying principle is background independence, but a very generalized version of background independence. You know, usually we think of background independence as this fact that, you know, quantum gravity doesn't depend on a fixed manifold, but sums over all manifolds. But this is some sort of covariance conjecture, some much more general version of background independence. It says somehow quantum gravity fluctuates over all possible theories. You know, any sort of thing that the theory could couple to, it does couple to, and it couples to dynamically. And so I think this is some form of some very generalized form of background independence. I think global symmetries is a version of background independence, because a global symmetry of a quantum system means that it can couple to an external background gauge field, but in quantum gravity instead, any probe of the system is an object in the system. And so I think this is why I would probably say that there aren't any others, because I think that if there were others, this would be a form of background dependence.
Right.
And so I think it's consistent for the quantum consistency of gravity that there is only really one fundamental theory.
But there's no choices, everything is dynamic.
Exactly. Anything that could be dynamical is dynamical.
Yeah. Any further comments, Federico? Oh, we have one online, please.
Can you hear me?
Ben?
Can you hear me?
Yes, we can.
I was just going to say this is a question that needs defining, and I agree that covariance conjecture is a good definition of the question. But maybe that's an important thing to keep in mind in other swampland questions. Sometimes we ask a big question like this, and the answer might depend on how you define the question. And so maybe you make a lot of progress once you realize, you know, what the right question is.
Yeah,
I think we don't know the answer yet.
Yeah, I think I agree with everything you said. That a good way to define what are two different quantum gravities, you know, it's like where you can say they're the same, they're connected by a domain wall, right? And if not, you can say they're different. To me, the interesting thing is that you can really start handling this question in ADS. Fine, maybe even if you can argue that string theory is unique quantum gravity in ADS alone, that to me would be huge. Julio? Oh, sorry, Federico was first, sorry, apologies.
Yeah, so I was thinking, if we say that swampland is about quantum gravity in general and not just about string theory, would it be completely unreasonable to invite in the next conferences some researcher working in other quantum gravities or discuss with them?
I think you do have a point. I'm on the hook because I might be organized in the next. Yes. I mean, we do engage with our committees. Like Julio just gave us a beautiful talk how to think about these kind of things from this matrix bootstrap. But let's discuss offline about the Julio thing. Okay, then we're doing it. Well, okay, it's not only up to me, but we're doing it. Yeah. Whatever Alessandro says. Yeah. Okay. Julio and then Tom.
Just a comment, which I think many of the things that at least I learned when I looked at some conjectures about what so there's the comments about what quantum theories of gravity don't have, like global symmetries, and that tells you that you have to have certain things, like the things that trivialize every border system, right? But there's still a question about dynamics, right? Which is a separate. So, like, if I tell you what are the particles in the standard model, and if you put some arbitrary constraint like renormalizability, you might be able to write a unique theory, and we know that that is not enough. So just knowing what the field content or what are the objects in the theory is not enough to narrow down the theory, right? So yeah, I think an important question is how many of these things constrain the spectrum of objects and excitations and in
kinematics versus dynamics.
Yeah,
I fully agree. So for instance, when you apply covariance conjecture in ADS, you relate to a dual CFT. It basically tells you there's any two CFTs are connected by a conformal interface. For that to be two vacuum of the same theory, I would say that the interface has to be transmissible. It should be able to get energy through. That's a dynamics. That is not, correct me if I'm wrong, Jay, but at present is not, the covariance conjecture doesn't say anything about that. We should do better. Please, Tom.
Yeah, I guess I have a question, I guess, for Jake or whoever wants to talk about the cobordism conjecture. I don't understand how any of the arguments that have been given for the cobordism conjecture could rule out the possibility that there's some landscape of string vacua and there's some landscape of vacua in some other totally unrelated bizarro string theory, quantum gravity theory. And these just two aren't related to one another whatsoever. I don't understand how we could rule out that possibility from.
I mean, it's kind of a formal thing, but you can, if in that scenario, you can form a theory which has a discrete parameter, which is specifying which of those two you're in.
And what's wrong with that?
That's a symmetry.
It's in the cobordism conjecture paper. I thought the argument you gave against symmetries.
It's a D minus.
You embed these into a larger, higher dimensional spacetime.
It's a D-1 form symmetry, and so I think the standard arguments against global symmetries, say from black hole physics or whatever, only really work for symmetries of dimension not quite that close to the dimension of spacetime. But the version of the cobordism conjecture that says that any two theories are connected by domain wall is exactly the statement that there are no D-1 form symmetries in quantum gravity. Just by definition. I mean, maybe that's not convincing to you, but yeah.
Yeah. Okay. I mean, yeah. I guess then I feel like we need a better argument against D-1 form symmetries that could rule such a thing out. Yeah.
If I may say something there, like because I agree that it's very unintuitive to me, at least, and maybe you disagree, but to me at least this becomes a lot more natural. Again, go to ADS and formulate in ADS CFT context. Now the question is a pure field theory question. I give you one CFT and another CFT. Is there a conformal interface, or isn't it? And if that would apply even to the two separate sets that you have, and when you formulate it like that, it's just a field theory question. Yeah, the answer might be there's no, or there's no conformal interface, or there is, but it's still a field theory question. It could be that when you formulate it like that, it seems a lot more, to me at least, much more normal that the answer could be yes.
Maybe I could just say one thing along those lines. So if you believe the things we tend to believe about ADS CFT, then if you had two bulk duals which were of these different classes, then you could take the CFTs and you could just, because they're quantum systems, you can always entangle their degrees of freedom. And then you can ask, what does the bulk look like? And if ER equals EPR is true, then the bulk has some topological connection between them. And so they have to be connected dynamically.
I think Julio wants to make a comment, and then Fernando.
It's actually a question related to that.
Okay.
You said that it's a question about the existence of conformal interfaces. But if you would say that any two quantum gravity theories at the end of the day, they will be connected by a series of domain walls. That would also mean that we can put a conformal interface between any two CFTs, right?
Yes.
Because you can just push them all together.
Yes.
So I think there's a concrete way of disproving this, which is if you find two CFTs and there is no conformal interface between them.
That's right. And for instance, you could imagine that there's counterexamples, for instance, in 2 dimensions with CFTs that have a global gravitation anomaly. But all those theorems assume something about how many degrees of freedom you have on the interface. They assume that you cannot have too many of those. I think that might be a way out. I thought about this. It's something I'm very interested in. Fernando, please.
Just to add more questions, actually, because since the 90s, of course, we knew from string theory perspective, there was a single string theory, single theory behind string theory. And I think that convinced everybody that should be one single fundamental theory, and that we can call it string theory or whatever, but it's only one theory. Even if people have been trying with other attempts. So my first question, probably to the people who voted in this 20%, what is it that they had in mind? And particularly, if nobody wants to say anything, at least you confess, Miguel, that you would have voted for that 20% last year without. But I would have voted for yes. I'm sorry, for no. 10 years ago, 20 years ago, or something. So I'm surprised that people like you, for instance, needed the covariatism conjecture to change your mind.
Okay, okay, what I mean, okay, maybe I would have voted too soon to tell. What I would have guessed is like out of, sir? Right, so the point is, okay, I'm gonna perhaps give my perspective. When you start studying string theory, it's all very nice and well, but you know little, you haven't seen too many things, right? I have not, and you want, yeah, this is nice, this gives Einstein gravity. How do I know? Because you don't have an appreciation of how difficult it is to actually get a consistent quantum theory of gravity. So maybe out of an abundance of caution, you might say, okay, I don't know. It's just the agnostic answer. That's what I would have answered. And actually, for me, the covariance conjecture was the first time I actually have a very concrete universal kind of independent from string theory argument that the answer to this might be yes. But I agree with you that
but I agree with you. I mean, the covariatism argument is beautiful. That's very, very, very convincing. But I was convinced much earlier because that's why we are looking for one single unified theory, and we don't know what string theory is. But whatever people try at the end, the idea is that there's a fundamental theory. If there are more than one fundamental theory, it cannot be just fundamental theory. Because, so in that sense, I would have been convinced before. But I fully agree that covariatism argument is beautiful.
I see.
So, but that's not my whole. I mean, that's only my first question. So the second question, I think, going back to what Liam mentioned, and in some sense, Thomas. But to Thomas, I would say the negative part that you mentioned, I would not put it as a negative because we already have quantum mechanics. We don't understand it, but we are happy. So in that sense, even the AIs will tell us something we don't. But to Liam, and I think that probably with the expertise that we have here, I was always very impressed with this initiative from Nima and Juan, I think Juan, about trying to prove a string theory from the bottom up, just to study amplitudes and so on. So I would like to hear what people think about that, if that is a feasible thing, that just to study the amplitudes and so on, you can actually single out what the theory should be. Because that's I know that Nima wrote it in this paper a couple of years ago, and I don't know, I haven't seen that many people following it up, but it looks very exciting. But I guess it may be extremely difficult. But maybe Julio, please.
Can I first answer the first question? Yes. And then I'll
that's okay. Yes,
like. So first off, uniqueness of string theory.
No, uniqueness. Yeah.
So uniqueness of string theory, we learned it in the 90s. First of all, I don't see why it had to be the case. It's beautiful and satisfying that it happened, but yes. I don't think anyone was certain that it had to.
I mean, we're after. Right? I mean, fundamental theory of nature. So one thing, all the other attempts which are very good. Oh, sorry.
Uniqueness of quantum gravity, since that's what that was the question.
Yes, and I understood it perfectly well, and my remarks say the same.
Well,
I mean, because whatever
with-
people are trying, nobody knows what their own theory is. But at the end, it has to be one single theory. You may not call it the string theory because it sounds very bad for some people. But at the end, the fundamental theory of nature has to be only one.
And what's the argument?
Sorry?
What's the argument again?
Because if it were two, just there is no point to have two and write down one fundamental theory.
By the same token, it would predict a single vacuum.
No. It's a
Why
different
not?
thing. No. There's one thing is a single theory.
Come
the
on,
other
do you
thing is
really believe that this argument is strong?
Sorry?
Do you really believe this to be a strong argument?
No. I think, but it's a way of
You
thinking.
your
That,
expectation.
because we're voting, we're not proving anything. It's just a
Okay,
vote.
but since you were
I mean,
asking, okay, so, for example, what about Vasiliev theories? I understand they have their problems.
Yes, it's already.
They're connected. So
connected,
they're
yeah.
connected to string
But
theory,
even,
but
I mean, if I ever.
some of them are.
Yes. Even I don't know if people of look quantum gravity may come up with something consistent. I'm sure it would be part of this fundamental theory. So I cannot
So
imagine.
a few years ago, so for example, it was discovered that you couple Chern-Simons to a single scalar, single fermion, you get a perfectly good CFT. So then dual to that, there will be a quantum gravity theory. So now to put one scalar, two scalars, so one scalar and one
Well, I will
fermion.
change.
Go on like this. I mean, now it looks to me like you will find the quantum gravity theory under your couch.
Yeah, but I think probably change quantum
There
gravity.
are so many.
No, I will change fundamental theory of nature. Also, I cannot think about quantum gravity without think about all the other interactions. Yeah, you can decouple gravity because it's weak, but you cannot decouple everything else. So probably if maybe if that is a misunderstanding, I would change quantum gravity by a fundamental theory of gravity.
Okay, I think
I think that's okay. So that changes the question. That changes the question a lot, and then I may start agreeing with you.
Very good.
But so this was the question on the.
Okay, since we agree now,
asked.
let's keep going because I've been told I'm under the clock. So yeah, but yeah, exactly. Let's move to Julio.
I'll just be very quick. I think the work we've been doing is trying to push that approach. And what we're finding is that there's a gap. Like we cannot single out string theory without new principles or ideas. Just pure consistency, unitarity, causality, etc., allows for a wider space of parameters. I show you a region. I didn't show you a point, right, in these plots. So we need either like more like technical power to see if we can reduce these regions, or some new principles. And there's been some ideas in the literature about like how can one narrow it down to the space spanned by the different string theories using the dominance of low spin states in graviton scattering or other ideas. But these are things that actually have come out of this program that I think it should be also interesting to talk to people in this community. But yeah, I think that is underway, even though it hasn't succeeded. Yeah. Okay. Thank you.
Okay, unless somebody has like a very present, very quick thing to say, I think we're gonna get going. Fernando tells me to proceed. So you bring it up with Fernando. All right. Do you think there's consistent, quantum gravity consistent infinite families of ADS vacua featuring scale separation? Possible answers are yes, no, or I would agree if the word infinite was removed. So the answers are, okay, people like to play it safe because I think this is certainly true no matter what, because we know examples. For instance, this paper by Kumru and Jeffrey and company, they found examples of scale separated vacua where at least in the BPS sector, which is what they could check, they found scale separation of a factor of 1,000 or 10,000. So of course those exist. They all come in finite families. The question is, do we have an infinite family? And I think that the feelings are kind of split here. I think it's one of the most important questions that we can actually attack very concretely, and I think we're making progress in those. Does anybody have any comments to make on these ones? Thomas, is Thomas around? Because you guys can tell, but I see I'm losing people. Of course, people are leaving. Oh, there's Thomas. No comment? I know. He says no. That means that you do not believe, Thomas? There's a
means I have little voice.
Okay.
Just want to comment that what is interesting, if you take DJKT, seems like an infinite amount of vacua, but the dual CFT seems to sort of be one CFT, as pointed out by the Oxford group. So something to think about.
Sorry, I didn't quite hear that. Like the last, I'm not playing jokes on you. Sorry, I didn't quite.
Is that the dual CFT seems to be sort of like unique?
But there's an infinite M family of them. Right?
Yeah, but it sort of is. I don't know what that means. It's a bit like large, N equals 4 and large and.
Yeah, I think we actually like. There's been interesting recent developments on these things, like by work of Fernando, Joan, and also Finn and Joe. Like on the people have discovered that there's this in some of the field, the supergravities that give you scale separated vacua like this. There's some fields which are dual to operators that have integer dimensions for no good reason, and to get the dimensions to be integers, the dimensions come from solving a quadratic equation. Generally, you have square roots and you don't get integers, but you do. And I think there might be something quite interesting there. And another interesting thing is that if DGKT is, for instance, working and we have a dual, there's a field theory as well to this. It's a field theory which has a central charge which goes like n to the 9 halves, which is bigger than the biggest that we know. If you put a stack of n branes, the biggest you can make the central charge go is n cubed, because that's what you get from n5 branes that you know how to do from string theory. The GKT, if it works, it's also revolutionizing, I think, understanding of field theory, conformal field theories themselves. Any comments? Any more comments on this one? Fernando is telling me to press on, so I'm gonna press on. Okay. Do you think that there's an infinite discrete set of vacua in string theory? So actually, this was a trick question. The answer is yes. Just think of it as 5 cross 5. There's infinitely many. Fernando, make a comment.
If there is no scale separation, why do you call it vacuum? Imagine that I define vacuum as a constant field configuration. That would rule out ADS 5 cross 5.
What do you mean constant field configuration?
Constant field configuration of the dimensions.
Well, I would say they're constant.
No, they're not, because you don't have a scale separation. So you cannot, this is a solution in 10 dimensions.
Yeah.
So, and your fields are not constant, but you have a sphere, right? This is not a constant thing. You don't have a constant field configuration in 10 dimensions, and you don't have a lower dimensional vacuum. So I would.
Okay, I see. So your point was that the scale separation, you were ruling this out.
I understand this is a trick thing, but if one way of understanding this question, you would rule out ADS 5 cross 5. I don't remember. I don't know.
Okay. Yeah. Okay. So I took, when I saw this question, I took it to mean Minkowski, like things where, like, because then that becomes a question of, are there infinitely many Calabi-Yaos? It's similar to that kind of question, right? That would be a particular case of
that would be constant field configuration. No?
Sorry, what? That would be constant field. I'm saying that in that interpretation, that's one way to make the question really interesting. We don't know if there's infinitely many Calabi-Yaos or not. And most people believe there's none. That's not true. And I kind of agree with them. I think I voted that. But also, like, I never have any satisfying understanding of why there's finally many, Calabi-Yaos. This was just not. Anybody has any insight on that? I'd love to hear. Yeah, me neither. I think maybe it's a bit out of reach question, but it's an important question. Okay, so there's no comments. Let's keep going. Do you think that there are quantum gravity consistent de Sitter vacua with lifetime significantly longer than the Hubble scale? Significantly. Yes, no, or yes, but we haven't found it yet. Even out, divided. So yes, a majority of people believe they actually exist. So significantly longer the Hubble time would mean, for instance, that something like TCC is wrong. TCC says that the lifetime is, as Lars was putting it, like the scrambling time. And 27% of the people believe that no, they don't exist. Anybody who wants to make a comment here about any of this? Like, why do you feel? Actually, my comment would be because, again, like the yellow answer is a bit like, okay, I don't know, which is fine. Don't get me wrong. But the people who feel more strongly, either way. Nobody? Okay, it's true. Please, Lars. Oh, they can talk. I mean,
maybe this is a little bit of a controversial opinion,
Uh-huh.
but I don't think for me, as like looking what the swampland community has done, I don't think for me there's really compelling evidence to really have a very sharp understanding that the lifetime of the sitter space should be something that is relatively short. I think for me at least, I'd like to be a bit conservative in the sense that I want to believe that I don't understand string theory well enough that I cannot make the statement that in our universe where we're living, which might be strongly coupled or something, that there would be not a de Sitter vacuum that's long lived.
Yeah, I see. I kind of agree, actually. I think that the conjectures that have been made on Swamp on the more the sitter side, they fall on the class of conjectures that Julio was talking before us, not directly connect. There's been efforts to connect to distance and so on and so forth, but this is not as solidly connected to things like the distance conjecture or weak gravity conjecture or no global symmetries as some of the other conjectures are.
Yeah, and I think something like TCC is seems very reasonable. Like when you look at stringy examples, you see like how potential behaves, but those are typically asymptotic statements. And I think to make the leap to really say that our universe should only live a scrambling time, I think it's difficult to reconcile with like what we know about or what we think we know about inflation.
Tom? Fernando, we're going over time.
I have a sociological comment, which is I think that the wording of the question must somehow have influenced the answers on this one.
That's right.
Because about 2 or 3 years ago when we had this workshop, a similar question was asked. Right. And I believe one, wait, there was a question about that.
Sorry, this is not from the workshop. This is again the Swampland poll we had online in 2021.
Okay. From this workshop, there was a question. Essentially, do you think de Sitter vacuum exist? Do you think we already have a construction? A lot of people said, I think de Sitter vacuum exist, but only one person felt confident that we currently have a construction.
I see.
Now it seems that this is ballooned to a quarter. I guess it's hard for me to believe that these two largely similar communities could be so different, because I don't think anyone would claim that in the last 3 years there's been a really compelling, explicit model of a de Sitter vacuum compared to what was there.
I fully agree with what you say.
Yeah, I think the question is different. It's not whether we have the model, but whether you think there could be. Also, I just wanted to make a comment. I think the answer would be different if you ask for a de Sitter, quantum gravity consistent de Sitter vacua of string size, with low energy Einstein gravity or without low energy Einstein gravity. Because I agree, you could always say, yeah, in the middle of the bulk, like everything's strongly coupled, there could be de Sitter. Of course, I don't know, I don't have any argument against that. I think that, but the question is, can we have a de Sitter with a low energy description that is Einstein gravity and that we can use for our universe? And that's a much harder thing to ask. And
just gonna say there, I for once, when I think about de Sitter, I really think Einstein de Sitter. But I take your point that people might.
Then maybe it doesn't happen in the middle of the bulk where everything's strongly coupled and string size curvatures without supersymmetry.
Yeah, I personally wouldn't count that as it, but again, I take your point. It's a good point. Anybody else? I had the 0 minute sign. I got upgraded to 5 minutes, so that's great. No more comments on this question? Not for question. Oh, okay. Well, we're getting to the end of it. Do you think that the ADS distance conjecture, ADS or the de Sitter distance conjecture implies that there's a tower of very light states in our universe? What do you guys think? Oh, no drum roll. Oh, forgot to do the drum roll. Anyway, so most people think no. So few people think yes, and I hope that the percentage that thinks yes is increasing more and more. So actually, Dieter was asking people what about their talks yesterday, and I wanted to ask him. I don't know where he is. Maybe he already left. Oh, that's a bit okay. Yeah, we're too late. I wanted to ask him because there's this idea that a few of us have been working on this dark dimension story, and to me, it's really the only thing I want to say here, which I think is interesting, is that it's already non-trivial that this is not impossible, that this is not ruled out by experiment. You could have a tower of light fields, and it's actually very constraining. It has to be out of all these asymptotic limits that we know, it really has to be the compactification of one dimension. It could have been ruled out, but it isn't. That maybe means something. Anybody, you could also, of course, understand this question in a larger sense. Anybody has any kind of comments?
Yeah, maybe I can make a comment here. And maybe it's also a question. I think one should make a difference between what we think the swampland program or the swampland does for us and what kind of model building does for us. So I think it's clear that we should make contact with nature through model building, but are you really believing that the swampland program singles out a certain model and, for example, this is the model and then we test it? So it fits better to your statement that it's interesting, it's not ruled out.
Yeah, so that's the way I think about it. I'm not saying, so if you ask me, I wouldn't say that the swamp or string theory over if this doesn't work. What I would just say, what I would personally say, and people might disagree, is that this is, I think, if we're at close to any infinite distance limit, and we might not, it might just be bulk model case, something like KKLT or something like that. But if we are asymptotically very close to an infinite distance limit, the only one which is compatible with the experiment is this one. So it makes sense to look into it. And it's amazing that it's not ruled out.
But you see that the statement cannot be true because it's stated that the distance conjecture implies this.
Oh, sure.
It's certainly logically not true.
You're right. This is more strongly worded than I would.
Like
this is
feeling. You have the feeling that this is the right scenario.
Yes, that's right. Yeah.
I mean, it makes sense, the exploration, because the cosmological constant is suspiciously low. And we are finding that when the cosmological constant goes to 0, towers of state appear. So it makes sense physically. It's a physical question. There is somewhere a tower going out. Anyway, I answer no, because I think that depends on whether there is scale separation. If there is no scale separation, the answer is yes, but if there is scale separation, the tower could be string scale. So technically, the answer I would say is no. There's no implication, but could be. It has to be tested.
Yeah, this is the same point that Thomas was making. That this is a stronger implication the way it's worded. Matt?
Yeah, I guess I'm curious about whether everyone interpreted the question the same way, because there's one reading of it, which is just, do you believe that a certain conjecture implies this, which doesn't imply that you actually believe the conjecture, just that if the conjecture is true, you believe that the states exist. So I'm wondering, for people who answered yes, because at least for me, I'm very surprised the percentage of yes is so high, because to me, there's very little evidence in favor of any argument along these lines. I mean, it's a possibility. I'm not saying we shouldn't explore it. It's interesting to explore, but I'm very surprised that the fraction of yes is so high. So I guess I'm kind of curious to hear from some of the yes people how strongly the yes was intended.
Anybody has a comment? If not, I can make a comment. I answered yes. I answered yes because I've been thinking about dark dimension a lot recently. I was like, yeah, dark dimension. I didn't give it that much more thought. But for instance, Thomas is right that the implication is stronger. For instance, that's what I believe. I just think it's a very interesting possibility, something that we should rule out. Anybody else? Okay, let's keep going then. I think we're getting to the end of it. Yes, we are. The last question was actually not a question, it was a sociological experiment to see how many of you would go for the troll answer, right? Imagine that a new experiment claims sizable primordial and B modes. What do you throw to the trash? The experiment, some refinements of the distance conjecture, string theory, myself should never do that, or the writers of this poll also shouldn't do that. And indeed, you're a bunch of trolls. 40% of the people was just like tired of the poll at this point, I guess, and they just they couldn't resist the opportunity to troll a little bit. To those of you who answered the writers of this poll, I hope you had fun. I need to go now. For the others, like for instance, I answered. Well, honestly, I've been messing with people who were wimping out a little bit in some of the answers. I wimped out in this one. I said some refinements of the distance conjecture because it's true. There's many refinements, and I'm not sure all of them are correct. So that's what I would throw to the garbage. But it's something interesting to like 20% of the people, or sorry, 20% said the experiment. Okay. No. You see, in 2015, when the bicep 2 thing came out, like sure it was not, there's no theorem or no whatever, but people were worried. Like from string theory, it's very difficult to produce a large R. Now we formalize a bit more that with the swampland, but the idea was there and people were worried. And some of us started writing swampland papers to try and understand this better. Like, yeah, no, you're gonna get large R from string theory. And then bicep turns out that you actually have to that happened already. You had to throw the experiment to the trash can. So, you know. With this, I agree. With this, I thought it was an interesting point to make, but I also agree it's not a nice general attitude. So those of you that throwing yourself, you should never do that. And yeah, there's 2% of people, I guess, like that means one person who would throw string theory to the trash can. So there's someone who is so sure about the Wigwright implications that if we see primordial tensor models, you throw string theory to the trash can. If whoever made this comment wants to explain, because I would be I'd love to share the feeling. No? Okay. So if there are no comments here, are there? Well, if they're not, oh, Elena has a mic, of course.
I mean, of course, it depends how sizable. But I would like to ask, like, okay, I'm sure if I say 3 times en blank or whatever, then there's a lot of discussion, depends on the refinements, the order of 1 factors. But now, if we say something really like bicep, it's really, I don't know, or 40 times en blank or 50, 100 times en blank. Is there consensus that that cannot happen? Or can we find a number that is consensus? 1,000 blank. Would we really say now as a community that this cannot happen and like evolve from bicep?
I think very good point. So okay, let's make an auction. Let's make an auction. I'm gonna start in 1 million, and let's see who like lowers the number more. So like, it's 1 million. Like, do we agree on 1 million? Okay, Jake's lowering the number.
Sorry, you're saying. No, I agree with you. No,
yeah. So, but you wanna improve. You wanna say. Okay, so how much would you take?
100,000.
100,000 is good. I got better than 100,000. No. Okay. Well. Yeah. Okay. Then it's lowering. Oh. Okay. We're playing hard. Okay. Well, you know, everybody can come up with their own number, but I think that's great. I think I would be very interested to hear from someone that doesn't agree that it's extremely unlikely that we can get, you know, a field range of 10 to the 10 in blanks. That concrete number. That's, you know, I'm being conservative, but well, anyway, I think it's a very good point. Nobody? I can quote everybody in this room saying as they agree that there's no field range bigger than 10 to the 10 in blanks. Okay.
Good, that's progress.
Huh? That's progress, yeah. Sorry?
Subject to what constraints? I think the first Oguri-Vafa conjecture is that the diameter of moduli space is infinite.
That the diameter of moduli space is infinite.
Yeah.
Mm-hmm.
So, I mean, to agree with phenomenology is a different question.
Yeah. Sure. Yeah. I was thinking about models. Yeah, connection to experimental. Yeah. Okay. So that was the last question. There's just one more very important thing to do before we leave. It's very important. It's last but not least. I think this was a great workshop. I had a lot of fun as usual. You know, I learned a lot of things. Great talks, all of them. And I think we should give a big round of applause to our swampland guys and conference organizers.